doing the bridges of Königsberg, or a proof as to why crossing all the bridges of Königsberg in this problem is not possible. And this is a proof devised by Leonhard Euler. So first I'll draw out the original picture of all these bridges. So the challenge is to see if you can create a walk through these bridges and these shores or islands or whatever, where you only cross each of these bridges once. The first thing that Euler does is he simplifies the diagram, or he just creates a clear diagram of what we're looking at. So he recognizes that each of these land masses you can just plot as points, and each of these bridges you can plot as lines connecting the points. So we've got our island here, got that, then we've got our big landmass here, got that, and then we've got our landmass that's above, got that, and then we have our one off to the side here, okay, and then we just draw in the bridges as lines connecting these dots. So there's one connecting here, and there's one across here, and there's two connecting this to this. So drawing those, two connecting this to this, drawing those, and there's one connecting this to this, drawing that one. So we get this nice little diagram that's a smaller, sort of cleaner, more understandable version of what we're looking at. So what Euler notes is that, what's the best way I can explain this? What Euler basically does is he works out the general rules for how you would need a bunch of dots and lines to be arranged in such a way that you could actually go around the graph that's drawn, or go around the diagram. So say if you just invented a new one of these, had paths like that, yeah, anyway, 2, 2, 2, 1, etc. Basically, you could make many of these and you could work out general principles for what will work for a walk and what won't. Like what will work in order to get you to cross each of these bridges, 1, 2, 3, 4, 5, 6, 7, etc. What arrangement these points and lines have to be in order that you can get a walk that works to get you around all of them. And what he discovers is that those conditions aren't met by this particular diagram, which means that there's no way of completing your walk through all the bridges of Königsberg without crossing back over them. So basically, what he works out is that for every point that isn't a beginning or an end point, for every bridge that goes in, if you want to keep going, you need a bridge that goes out. And it's fine if you have two, so say you could go in and out, and then in and out, but basically you need an even number unless you're at some kind of end point where it's okay to just go in and stop, or it's okay to just go out and stop. Like if you're at the beginning, you can just go out and then wander around the maze, or if you're at the end, you can just stop at the end and you don't need to go anywhere. So his general rule, though, is that for these types of diagrams, if you want to be able to cross all of the bridges or the lines, or in graph theory we'd call them edges, if you want to be able to traverse all of these edges, then except for at the beginning and end point, which can be the same point as well, you could just have a system like that. For all these points except the beginning and end point, it's necessary to have an even number of lines coming in and out. Now the problem is we see that there's 3 here. It's 3 here. 4 here, so we might be right there. 5 there, actually. So there's 3, 3, 3, and 5. At maximum, we could have 2 that have an odd number of these lines coming off them. But we have 4 that have an odd number of lines coming off them, which means that trying to create a walk through these where you cross just each of the bridges once is just never going to work.